Hello friends, so now I'm going to deliver the final lecture series regarding the satellite navigation systems and its overview and introduction. So before going through this lecture, I would suggest you all to follow my previous two lectures in detail for the satellite system, the GPS. It is just an abstract or gist about all the last two presentation that I have already delivered to you. So it is also very important topic under atmospheric and the space science for satellite, receiver, the trilateration, all the aspects. And importantly, it will be covered in the Combined Geoscientific examination, BARC examination. So friends, let's go into detail. So now the thing is about satellite navigation system and its component. These are all network of satellites which is particularly used to provide location and time information on the ground, and the wide range of application is there in every aspects. So generally the GPS uses a number of satellites to transmit signals. The receivers are placed on the ground, and it by the method of exact time calculation they will measure the distance. GPS is having the excellent precision or accuracy of 3.3 to 5 meters, and it can be affected by factors like satellite positioning, the atmospheric system. Other satellite navigation system includes, apart from GPS, the GLONASS, the Galileo, Beidou's, IRNSS. So let's now discuss about the principle of the satellite navigation. So there are three aspects: signal transmission, trilateration, and the signal reception. So satellite generally can transmit radio signal, which is having the information about the position and the time. Then there is a process called trilateration, which I have already discussed in the previous lectures, that by analyzing the distance to multiple satellites, the receiver can determine the precise 3D location on the Earth. And there is a third concept, that is signal reception. That means that receivers on the detector ground detect the signals and calculate the distance to each satellite based on the time it takes the signal. So the global satnav systems, the satellite systems are there apart from GPS, what I have mentioned, the GLONASS, the Galileo, and the Beidou systems. And all the pictorial depiction of the GLONASS, the Galileo are there for the clear visualization. So there are mainly three components within the satellites, I mean GPS: the space segment, the user segment, and the control segment. So details I will be discussing in this lecture. In that segment there you can see the 4 satellites per orbital plane with the 55-degree inclination to the equator. So the GPS system consists of the parts about space segment, which is the constellation of more than 20 satellites having the information of timing and precise time information. And there is also user segment that consists of mainly the GPS receiver, that they receive and process the signal from the satellites. And we know the receivers are found in variety of devices such as smartphones, cars, aeroplanes, and the ships. The use of GPS receivers in various of the device you can see by the pictorial depiction: the ships, cars, aeroplanes, smartphones, the mapping systems where we can find the use. And there is also another segment called control segment. So there are, what are the components: master control station, the ground antenna, different components are there, monitoring station, the tracking station for the control system of the GPS. Similarly for GLONASS, there are also control systems are there: uplink station, monitoring station, telemetry and tracking, and control systems where all electronic control parameters are there, and laser tracking station. These are the control system segment for GPS and the. So if we are talking about the GLONASS and the Galileo constellation for the satellite, so what are the parameters are there? So for GLONASS, there are 3 orbital planes with the orbital time of 11 hours, and they operate on different carrier frequencies on L1 and L2. So Galileo full constellation that provides up to 30 satellites, out of which 24 will be operational and 6 will be in standby. So 3 orbital planes with 56-degree inclination to the equator and 23,000 around kilometer above the Earth, they are placed that for Galileo. 40 knots orbit is there. So now when you're talking about the system components, the control and user segments, you can see in the car, in the field, there's a user segment, the receivers are placed in the GPS user. There is a control through the space station, the control segments of the GPS user. So mainly for GPS operation, the three ranges are to be resolved: the lat, long, and the height. And the fourth range is the receiver clock up. So mainly in my previous lecture I have talked about the time trilateration for the GPS. Now in this I will be showing about the receiver and the satellite signal. So satellite signals are mainly two codes on it, the C by A and the P code. C by A code is based upon the time for the with the very accurate atomic clock that is within the satellite. It is the digital code that is the pseudo random. It repeats 1000 times per second. The receiver also contains a code that is used to generate that is matching the C by A code. So that the satellite signal is having C by A code and P by A code, and it is a receiver signal. So the time difference can be shown. The time taken for the signal to reach the receiver is the distance between that two signals. So the GPS receiver will then be able to match or correlate the incoming satellite code to the receiver generated code, and the time taken by the radio signal to travel from the satellite to the receiver is then calculated. So it is the whole procedure by which the satellite to receiver signal is calculated. I mean the signal calculation is being done GPS, by. So mainly there are many challenges and limitations due to the signal interference factors there, that ionospheric condition, the atmospheric condition that can disrupt the signal, and it should have a impact on the performance. They are generally vulnerable to the uh, jamming and cyber security threats. So last point is the over dependency of the satellite can create risks if the systems suddenly available. So there are future developments in the satellite navigation system. I mean now the accuracy is 3 to 5 meters, so there can be a centimeter level precision for the advanced satellite technology and to augment it. So it can mitigate the vulnerabilities and can improve the resistance to interference and all the disruption. What I'm talking about, uh, that disruption, and it can integrate with other technologies just like I previously discussed: AI, Internet of Things, and autonomous systems for advanced application. So global expansion must be there. The rapid increase in the regional and the global navigation satellite system worldwide maybe. So this is my uh, channel for the physics and geophysics. So you can share it, like it, and turn on the bell notification icon to get more updates for the whole lecture series from 1 to 3 under atmospheric and space science. Thank you all. Hope you are all good. Please follow this lecture, and if with any doubt, feel free to contact me or mail me so that I can get back to you and answer your question. Thank you.